In this video, let's revise Chapter 2 Polynomials. Polynomial in terms of x is denoted as p of x. The highest power of x in p of x is called the degree of the polynomial p of x. Let's learn what is a zero of a polynomial. A real number k is said to be a zero of the polynomial p of x when p of k is 0. That is, let's consider a polynomial 2x plus 3. Here we can say minus 3 by 2 is a 0 of this polynomial. That is, if we substitute the value of x as minus 3 by 2, we get the value of the polynomial as 0. Let's just quickly check it. So the polynomial we have is 2x plus 3. Let's substitute x as minus 3 by 2. So we get 2 into minus 3 by 2 plus 3, which is equal to 2 and 2 get cancelled. So minus 3 plus 3, which is 0. So you see that when x takes up the value of minus 3 by 2, p of x reduces to 0. That is why we say minus 3 by 2 is the 0 of this polynomial. Now, polynomial of degree n has at the most n zeros. That is, if the degree of the polynomial is 2, then it can have up to 2 zeros. It can have either 2 or 1 or no zeros at all. So if the degree of the polynomial is 3, then it can have at the most 3 zeros. Now, linear polynomial. A polynomial of degree 1 is called a linear polynomial. Generally, it is expressed as p of x equal to ax plus b. You can see that the highest power of x here is just 1, so it is a linear polynomial. A and b are real numbers. A is the coefficient of x and b is any constant. Here, a should not be 0. If a is 0, then this entire term will vanish, leaving us with only constant. So p of x will no longer be a polynomial in terms of x. So for this expression to be a linear polynomial, the coefficient of x, that is a, should not be equal to 0. Now this is an example for a linear polynomial. And the degree of a linear polynomial is 1, so it can have at the most 1 0. Now graphically, if we plot this polynomial 2x plus 3, we get a straight line. So graph of any linear polynomial is a straight line. 0 of the polynomial is the coordinate of the point where the graph intersects the x-axis. So here this is the polynomial line. Where does it intersect the x-axis? Here. It's in between. This is the point where it intersects the x-axis. So it's between minus 1 and minus 2. So it is nothing but minus 1.5 or minus 3 by 2. That is the 0 of the polynomial 2x plus 3. So this is all about linear polynomial. Let's see about quadratic polynomial. A polynomial with degree 2 is called a quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c. Here a, b, c are real numbers. Again, a, that is the coefficient of x square, should not be equal to 0. If a is 0, then the entire term will vanish. There will be no x square term. It will just be bx plus c, so it will reduce to a linear polynomial. For this expression to be a quadratic polynomial, a has to be not equal to 0. X square minus 3x minus 4 is an example of a quadratic polynomial. Graph of a quadratic polynomial is in the form of a parabola. It's a U-shaped curve. Can be either open upwards or open downwards. It depends on the coefficient of x square. When the coefficient of x square, that is a, if a is positive, the curve is open upwards. If a is negative, then the curve is open downwards. Here again, wherever the curve cuts the x-axis, those points will give us the zero of the polynomial. So let's see different cases. Case 1. Here the parabola intersects the x-axis at two distinct points. This is one point of intersection and this is another point where it cuts the x-axis. So we can say that the polynomial p of x has two distinct zeros. And the zeros can also be found by just seeing the graph. You have to note down the x coordinate of the points where it intersects x-axis. X coordinate of this point is -1 and x coordinate of this point is 4. So we can say -1 and 4 are the two zeros of this polynomial p of x. Next, case 2. Here the graph, that is the parabola, intersects x-axis exactly at one point, or you can even say it is two coincident points, here A and here again A. So there is only one distinct zero for this quadratic polynomial. That is, the zeros will be equal to each other. It will be either 1, 1 or -1 and -1, 2, 2 and so on. So you have just one distinct zero for such graphs. Now case 3 is where the graph is entirely above the x-axis or below the x-axis. It never intersects the x-axis. So such quadratic polynomials have no zeros at all. Now let's see the relationship between the coefficients a, b, c and the zeros of a quadratic polynomial. If we denote the zeros of quadratic polynomial as alpha and beta, then the sum of the zeros, that is alpha plus beta, is given as minus b by a, where b is the coefficient of x and a is the coefficient of x square. So sum of the zeros alpha plus beta is minus b by a. Similarly, product of the zeros, which is alpha into beta, is given as the constant term c by a, where a is again the coefficient of x square. So this gives the relationship between the sum and product of the zeros and the coefficients of a quadratic polynomial. Now here is an important note. If we say alpha and beta are the zeros of p of x, then we can write x minus alpha and x minus beta are the factors of p of x. So p of x can be written as a constant k into these two factors. For example, when we say 2, 3 are the zeros of p of x, then you can express p of x as a constant into x minus 2 will be one factor and x minus 3 will be another factor. Time for MCQs. If one zero of the quadratic polynomial x square plus 3x plus k is 2, then the value of k is. Options are 10, -10, 5, -5. For the given quadratic polynomial, 2 is one of the zero. So if we substitute x as 2, the value we get will be 0. Using that, we can solve and find the value of k. So p of x is given as x square plus 3x plus k. Since 2 is a 0 of p of x, we know that p of 2 will be equal to 0. So let's substitute x as 2, which is 2 square plus 3 into 2 plus k is equal to 0. 4 plus 6 plus k is equal to 0, solving which you get k is minus 10. So answer is B, minus 10. If one of the zeros of the quadratic polynomial k minus 1 x square plus kx plus 1 is minus 3, then the value of k is, options are 4 by 3, minus 4 by 3, 2 by 3, minus 2 by 3. Same logic, we will substitute x as minus 3 and equate it to 0, and let's find the value of k. So substituting x as minus 3, you have k minus 1 into minus 3 square plus k into minus 3 plus 1 will give you 0. That is, we are doing p of minus 3 and equating it to 0. Minus 3 square is 9 into k minus 1 minus 3k plus 1 is equal to 0. 9k minus 9 minus 3k plus 1 equal to 0. 6k is equal to 8. So k will be 8 by 6, which is 4 by 3. Option A, 4 by 3 is the right answer. Next, a quadratic polynomial whose zeros are minus 3 and 4 is. So in this question, the zeros are given and we need to frame the polynomial. So let alpha be minus 3 and beta be minus 4. We discussed that if alpha and beta are the roots or are the zeros of the polynomial, then the polynomial can be written as a constant k into x minus alpha x minus beta. So just substitute the two zeros. X minus of minus 3 will be plus 3 into x minus 4. So simplifying this, you will get x square plus 3x minus 4x minus 12, which is x square minus x minus 12. Now, k is a constant and it can be any real number. Here we have the coefficient of x and the constant as negative terms. So let's check the options one by one and choose the most suited one. Here the signs are minus and plus. Here the coefficient is plus and the constant is plus. Here we have coefficient of x as a negative number and the constant is also a negative number. So let's see what happens if we choose k as 1 by 2. We get p of x as 1 by 2 into x square minus x minus 12, which is nothing but x square by 2 minus x by 2 minus 12 by 2 will be 6. So option C is the right answer. If minus 1 is a 0 of the polynomial p of x equal to x square minus 7x minus 8, then the other 0 is. So normally we denote the zeros as alpha and beta. Here one of the 0 is given. So let alpha be minus 1 and we will try to find beta. Now p of x is x square minus 7x minus 8. Remember, we had this relationship between the zeros of the polynomial. Sum of the zeros is minus b by a, where b, a are the coefficients of x and x square respectively. So in this polynomial, coefficient of x square is 1, so a is 1. Coefficient of x is minus 7, so b is minus 7. Constant c is minus 8. So alpha plus beta is minus b by a. Alpha we know is given as minus 1 plus beta is equal to minus b is minus of minus 7, which is 7, divided by a is 1. So you have beta as 7 plus 1, which is 8. So beta is 8, which is the other 0 is 8. If you want, you can just substitute 8 in the polynomial and check. 8 square minus 7 into 8 minus 8. 8 square will be 64 minus 56 minus 8, which reduces to 0. So 8 is the other 0. The zeros of the polynomial r of t is equal to minus 12t square plus k minus 3 into t plus 48 are negative of each other, then k is. Here instead of x, the polynomial is in terms of t. So instead of p of x, we have r of t. Only the variable has changed. It's given that the zeros are negative of each other. Normally we denote the zeros as alpha and beta. Since they are negative of each other, we can have alpha to be minus beta. One is equal to the negative of the other. Sum of the zeros alpha plus beta will be 0 because we know that alpha and beta are negative of each other. We also know that alpha plus beta is minus b by a. Let's write down the coefficient separately. A is the coefficient of the square term, so it is minus 12, and b is the coefficient of t, which is k minus 3, and constant c is 48. So substituting sum 0 minus b by a will be minus of k minus 3 divided by a is minus 12. So k minus 3 will be 0 and k is equal to 3. So option A is the right answer. If the zeros of the quadratic polynomial x square plus a plus 1 into x plus b are 2 and minus 3, then a is minus 7, b is minus 1, or a is 5 and b is minus 1, a is 2, b is minus 6, a is 0 and b is minus 6. So the zeros are given. If you substitute the zeros, the value of the polynomial will become 0. That is the concept, and thereby we can solve for a and b. So 2 is a 0, so p of 2 will be 0. Let's substitute x as 2 first. 2 square is 4 plus a plus 1 into 2 plus b is equal to 0. We will get an equation in terms of a and b. 4 plus 2a plus 2 plus b is equal to 0. So 2a plus b is equal to minus 6. The other 0 given is minus 3. So if we substitute minus 3, again the value will be 0. Minus 3 square plus a plus 1 into minus 3 plus b is equal to 0. 9 minus 3a minus 3 plus b is equal to 0. So minus 3a plus b is equal to minus 6. So these are our two equations in terms of A and B. We need to solve for them. We can actually equate both are minus 6 and minus 6, so we can just write 2a plus b is equal to minus 3a plus b get cancelled, so 5a will be equal to 0 and a is equal to 0. Substituting a as 0 in this equation, we get 2 into 0 plus b is equal to minus 6, so this becomes 0, b will be equal to minus 6. So the answer is A is 0 and B is minus 6. That's the end of the video. Thanks for watching and hope you liked it. Please subscribe to our channel and also press the bell icon to receive notifications as and when we upload new videos. Thank you and have a nice day.